You're not going to want to miss this episode of the AI show where we talk about a brand new service called Metrics Advisor, anomaly detection, alerting, graphs. It's pretty impressive. Make sure you tune in. Hello and welcome to this episode of the AI Show where we're going to look at a brand spanking new service called Metrics Advisor. I've got a special guest with us today. Hello, my friend. Why don't you tell us who you are and what you do?
Hello, Seth. Hello, everyone. I'm Chun, PM of Metrics Advisor. And today I'm here to introduce to you this brand new cognitive service, which is Metrics Advisor. And we are going to announce it in public preview on this Ignite.
So, why don't you tell us a little bit about what it is?
For sure. Seth, but that's going to take a lot of time if I'm going to talk about everything of it. But you know what? We do have a web portal. I think I can just show that to you and show that to everyone. Does that
That
sound
sounds
good?
awesome. Let's do it.
So this is the web portal of Metrics Advisor. And you see that this is basically able to monitor time series and do root cause analysis on anomalies. So with that, this web UI will enable you to build everything as a pipeline from adding data feed. And this is basically try to connect the instance to your data source. And the service will pull time series data from your data source and it will monitor everything from there. So I have a screen open here. So this is basically already running anomaly detection. And when anomalies are detected on this web portal, you could also specify, configure some alert settings so that this platform will actually send you emails or send some webhook API calls so that you will know that there's something wrong with the data. And when you know that, then you can come back to this portal. And I'm going to show you something very interesting here.
Before you go there, I have a couple of questions, if that's okay. So let's go back to the first tab, that one right there. So basically, what you're doing here is you're adding a feed to time series data. And for those that don't know, what is time series data?
Oh, yeah, for sure. This is not about other data. This is because this is running anomaly detection and monitoring time series data only. So instead of explaining what time series data is, I'm just gonna show you an example of time series. Does that work, Seth?
That's perfect.
Okay. Yeah, I got this in my clipboard. So let's pull it first. Hope there's some data. Yeah. So let's first skip this part. Actually, if you look at this is the raw data that's pulled straight from the data source. You see that first let's ignore the first two columns and let's look at the timestamp and value. So time series data is basically a timestamp plus value, the measure, the KPI that you want to monitor here. And so this is what we call time series. It's an array of the tuple of timestamp and value. But I want to go beyond that. So because in this platform, we are not only monitor um, time series, we monitor multi-dimensional time series. We're able to do that. So actually, you're already seeing this. So on the left side, these two columns, the channel and region, they are also the features, so to speak, of this value. And this value, by the way, is actually a DAU, a daily active user of a website. And that is the measure that we're really interested in. The timestamp is timestamp, but the channel and the region, they are trying to breaking down the DAU into different channels and different regions. So in our platform, we are able to specify these two as different dimensions, such that we will have multi-dimension data and we can start from there to ingest data, ingest multi-dimension data. And what I'm going to show you here is that we are able to roll up the data. So this is automatic. I can specify different algorithm here, but basically we can summarize all the DAU data by the different dimensions here, the channels, the regions, And that will give us an aggregated view as well, which I will show you later on the second tab. And that will enable a lot of cool features.
This makes sense. So basically, this data represents an aggregation over certain dimensions. Like, for example, this is daily active users on a website. It could be the number of products you put out in a day, depending on what the weather is like, plus some other thing. And so, this is really about looking at a series of things that happen in your business looked at across multiple dimensions. Is that right?
Yes, exactly, Seth. You got it right. So, and with that, I'm going to show you the fancy charts because I think that's more, direct, and that's more visible to you of the data. That's much better than the table, right? Um, so this is the data that's previously added to this instance, and it's being pulled. And now you see that we have these multiple charts. They are basically different models monitoring different slices. And by slice really means a value combination of the dimensions. So here we have direct, we have ONO, we have different regions, United States, but the most interesting part is the one that aggregates all. So here we got this, sum of channel and a sum of region. So this is the automatic aggregation that I have specified earlier, and it's an aggregated view of your data. And what we have all the different models monitoring every single slice and the aggregated ones as well.
So just to be clear, so this would basically be the first top left-hand corner of a chart is basically looking at total daily active users across all dimensions, and then it slices across all the other dimensions to give you a sense for what is actually going on, not only overall, but across multiple dimensions. What do those red dots indicate?
Oh yeah, that's really the most beautiful part of this platform. We are running monitoring of the data, and we are monitoring it for anomalies. So you see, we have all these settings here. These interesting and powerful settings. Therefore, running anomaly detection. They are detecting anomalies from the data, and they're detecting anomalies from both the aggregated DAU as well as the sliced DAU. So you can have an overall setting. You can have different settings for each time series, which we call. So these are all different time series, by the way. So these red dots, to your question, says they are anomalies that's detected by the models because we have a collection of models under the hood. And you know what? When an anomaly actually is detected, we are able to set the alerts, set some alerting to basically to alarm you that okay, there's something wrong with the system, but with data, with your DAU, through email, through webhook, through all the tools. So you can trigger anything that you want, and from there, what I'm going to show you says is what the aggregation will actually help. After you notice an anomaly, an incident.
So let's pause right there because I want to make sure I digest this properly. So you just basically hooked up the data and you get all of these charts basically for free.
Oh yeah, for sure. This is just a one data feed. You see that I connect one data source from it. I just specify the schema, and now we got, if not tens of thousands, I think there are a lot of different values of the dimensions, and all these different sizes are being monitored automatically for free. Yeah.
And then the second question is basically we're ingesting these you're ingesting these things and then you're finding where there's data that's anomalous and you can even alert folks whenever the data is anomalous.
Yes, so that's what I'm showing. What I was showing about this alerting feature. whenever there's something wrong with the system, when sorry, not with the system, with the data, you could be alerted. You could have different settings for alerting, for different sensitivity, for different severity. You can you can opt to some really serious anomalies, some really serious instance, as opposed to someone who will prefer to monitor a lot of it. So that will be used with lower sensitivity and a lower bar for alerting. Does that make sense?
Absolutely. And so then the next question is this, and hope maybe you'll have an answer for this. Just knowing that there's an anomaly is great, but is there anything else I can do to figure out like what actually is going on?
Oh yeah, so that is something that I want to show you. And so basically, when you got an alert, from the alert, if it's an email, from the email, you can jump to the next page, which I'm going to show you here. Let's just jump to that page to save your time. Now, if you look at this, this is basically an alert, an incident that's detected from the system, and we have a unexpected drop here for region for the DAU that we are monitoring. Actually, if you have an unexpected spike, that will be also an alert, which is a good alert, by the way. So here, when the data goes anomalous for the aggregated DAU, you are able to drill down to the different dimensions that we specified earlier. So that's how the dimensions are used. You aggregated everything, you aggregate all the regions or the channels. Now, when there's something wrong with the overall DAU, you are able to drill down to using this tree to different regions, different channels. So here we're seeing that this direct channel and of United States is contributing the most to the current anomaly. So that might be one of our root causes. Here we actually have a bunch of root causes, or most likely root causes. So this is basically helping you to save time, not to spend any time on those that less relevant to these anomalies, that are doing great. There's no job there, so you can focus your energy on this direct channel and United States, and maybe a few others from this recommendation as well.
So basically, this is telling me that this drop in daily active users is coming mostly from the United States across multiple channels.
Exactly. That's a recommendation, and that information, is retrievable from this UI, uh, as well as API. I should mention earlier. So because this is a platform, you can have everything on this UX, but you can also accomplish almost all the tasks, including retrieve the root cause from the REST APIs as well.
I see. That's pretty cool. So, what other ways do I have to actually look at this data to get a sense for what's going on underneath?
Oh yeah, so that is something I'm really excited about. Beyond this tree, apart from this fancy tree here. So because the diagnose tree or the root cause tree here is basically for the cases when your data can be aggregated into using different dimensions. But what about when your data is not able to aggregate at all? So here comes something that's very fancy, which is the matrix graph. And before we jump into this, let me show you just one really data feed that I've added earlier, which doesn't have the dimensions that we mentioned earlier. So this is the one. So this is basically the application telemetry or IT telemetry of a complex system, which we call an infra data feed. And in this data feed, there are multiple signals of telemetry, like throughput of database of and CPU usage, and disk I/O, and so forth. So in here, let me show you the charts. They are quite different from what you saw earlier. So you see there's no aggregated view. It's just monitoring each one of them separately. And with that, you are not able to get a tree from it because it's not breaking down anymore, breaking down on the dimensions anymore.
So let me see if I understand. So basically, what you're saying is that you can import non-dimensioned time series data that basically has a timestamp and a value, and you can find anomalies in that, but you really can't use that with any. It's really on its own, this time series, and it has no other way of knowing about anything else. Is that right?
Yes, and the tree is not gonna help here.
Yeah.
Yeah. So I'm going to use this different thing to help in this case. If you have all these different metrics and they're independent, they have nothing to do with each other, then that's not gonna help. So we're gonna define something here, and we have a tool which is matrix graph. This is something that's kind of static. You can define the relationship, the dependency relationship between the metrics, the different time series, so to speak. And then you will have a dependency graph here. For example, let's delete this one actually. So, I can delete anything from here. I can add anything to it. I can even add a cross metric, cross data feed metric to this graph. For example, this is from DAU, while these three are all from the infra. So when that is defined statically here, there's a dynamic thing of it. So if we switch back to the previous DAU, because I've defined the DAU dependent on web latency, let's see the magic here. So if we know that DAU is dependent on web latency, and DAU has something wrong here, like previously I clicked on one of the instance, and you know what? This is showing that web app latency is also anomalous at the same time, and MySQL throughput as well. But CPU and disk looks good. So that is basically tracing down the path, tracing down the dependency path. And that this graph here is telling you that, hey, you're gonna spend some time on MySQL because following this path, this looks most likely to be the root cause. And don't spend time on CPU and disk because they are okay. So if you see something in MySQL, to see something wrong there, this might be the root cause that you want to find out.
So let me see if I understand this, because if this is what I'm thinking, this is pretty amazing. Basically, you added several disparate time series that represent different things. You map them together as dependencies, and then showed that at the same time, multiple things had anomalies. And it looks like it stopped at MySQL, which means that MySQL had a problem in the United States that caused the daily active users to go down, which makes sense. Is that about it?
Oh yeah, oh yeah. So that is already giving you a lot of information. I mean, it's not maybe the real root cause or the issue that really causing the current drop. And let's say for this example, eventually they found out that there is SQL query that has some regression there, but the information that you've mentioned, the United States region, the MySQL is definitely helping pointing to the right direction. So they can start from any SMEs, any developers, and can start from there and do the investigation, and that will save a lot of time.
And this is really cool, and all just because I added a couple of feeds, mapped some of these metrics together into dependency graphs. Now I'm getting a holistic view of what's going on in all of my systems. I mean, that's what it feels like. Is that what's going on?
That is exactly what it is.
So what other cool things are in Metrics Advisor? I mean, I can't even imagine how you're going to go above what you've already done.
Okay. So there are a few things here that I want to show off, because that's something that definitely gonna help customers, and especially for those customers who know their data really well and who want to have more control over the model. So for example, here we have multiple models that's already using this smart detection algorithm um, to detect anomalies from it. And we have these settings here and that all the flexibility. But one more thing that gonna help is we have this feedback. So this feedback is basically helping customers who know their data, who know their anomalies, and to try to educate the system that okay, you know what, this anomaly is not an anomaly. It's something that's expected. Try to avoid alerting me in the future. So this is the feature that's gonna help, and that's implemented using reinforcement learning. And this is the feedback to the model. And we all have all these different feedbacks here: anomaly, change point, period, as well as comment. I don't think I have the luxury to explain everything here today, but this is all possible, and I encourage you to explore this, and you will love it.
So this is all pretty amazing just by virtue of adding some data feeds, hooking them up together in a graph, and then maybe even going the extra mile and telling the system these are anomalies and these aren't. You're able to create a system that really gets to the heart of where your data is showing problems, which is really cool. Are there any final things to add? I mean, is there an API? Is there how do I can I access this?
Oh yeah, sure. So when we mentioned about the root cause, I talked a little bit about the API. And actually, we have a rich set of REST APIs that you can custom or build your own solution programmatically. And you what the we will actually launch a few, actually four languages for SDKs of the service as well. So that will definitely help your coding much easier. So yes, that we have all the REST APIs, almost all the REST APIs that can be used to build all the features that I've just showed you.
So this is amazing. Where can people go to find out more?
So Seth, these are the links that will help customers get access to this today. Because the service is already in preview. So you can go to ak.ms Metrics Advisor, and you could also choose to connect with us, the product team, using this email. And you know what? We also have a public community on Teams. So we everybody from the product team is also there, as well as some of our customers and partners. So feel free to join that as well. Go to this link. There's a form, but and you can ask any questions there. But remember not to say anything sensitive there because it's public.
Awesome. Well, I'm going to put the links up there one more time just so everyone can get a look at them. And then let me just end by saying thank you so much for spending some time with us, my friend. We've been learning all about Metrics Advisor, something you should use today. I'm very excited about it myself. Thank you so much for watching, and hopefully, we'll see you next time. Take care.